Vector. Each of the physical quantities are placed in two categories, either as scalar or vector. First, we will discuss scalar. Scalar quantities are those quantities that is completely specified by positive or negative number with appropriate units. For example, mass, length, time. These are actually scalar quantities. Means you can say scalar quantities are those quantity which is having magnitude and they never have any direction. The example is mass, length, time, etc. Whereas a vector is a physical quantity that must be specified by both magnitude and direction. Means vector are those quantities which are having magnitude as well as direction, and they must follow certain rule which we will discuss later. The question arises how to write vector. So we can write vector as, if I want to say that A is a vector, if I want to prove that, say that A is a vector, then I will write here A and put an arrow over it. So it represents a vector. Or I can write it by bold letter. This is also read as vector A. Now vector is made up of two things. One is magnitude. So magnitude of vector A is written as mod A. This is also written as simply A. This is called magnitude of vector A. It only represents the measurement of vector A. The second is A cap. A cap is a unit vector. It only represents the direction of this vector A. It is read as A cap. It is also called unit vector of vector A. It is called unit vector because mod of A cap is always 1. It doesn't have any unit and it only represents the direction of vector A. Now, here we need some standard unit vector because as we know, if I say A cap, so it is impossible for any reader to know its direction. It is impossible to know its direction because direction is infinite. So we use I cap. I cap is a unit vector along positive x axis. So this vector, this direction, positive x direction is written by I cap. So I cap is a unit vector which only represents the direction along positive x axis, whereas minus I cap is along negative. This is minus I cap. Minus I cap is a unit vector which is along negative x axis. J cap is a unit vector along positive y axis. This is along positive y axis, whereas minus j cap is a unit vector along negative y axis. K cap is a unit vector along positive z axis. This is k cap, and minus k cap is along negative z axis. In this direction it is minus k cap. So these are the standard unit vector which we will use. Also mod of I cap and mod of j cap, mod of k cap, mod of minus I cap, mod of minus j cap, mod of minus k cap is always 1 because all these are unit vector. Now the properties of some vector, some properties of vector. First, if a vector is displaced parallel to itself, it does not change because as we know it is having magnitude, it is having direction. A vector is made up of magnitude and direction. If the magnitude of the vector and direction of vector is same, suppose if I move this vector in this direction, so as we know this is a vector A, this is vector A. It is made up of two things. One is magnitude and the other is direction. If I move this vector from this point to this point, this vector will remain same because its magnitude is same, its direction is same. Means vector is independent of its position. If I put it here, then also it is vector A. If I put it here, then also it is vector A. So irrespective of position, magnitude, if magnitude and direction of the vector are same, so the vector will remain same. So this vector and this vector both are actually similar vector, or you can say both are same. Next thing, if a vector If the frame of reference is translated or rotated, vector does not change, though its component may change. Means, if I rotate this x-axis, suppose this is our x-axis, y-axis and z-axis. This is x-axis, y-axis and z-axis. This is a vector A. Since this vector is made up of magnitude and direction, if I rotate this xyz axis, if I make this y-axis, x-axis and z-axis like this, but the vector remains same like this, so if the magnitude and direction of vector is same, then rotation of this coordinate system never change the vector. Its component may change. The next property is two vectors are equal if their magnitude and direction both are equal. Suppose this is vector A, this is vector A. If I move this, if the length of this vector, if this is vector A, if I draw a vector which is also having same length and same direction, if the length of these two vectors are same, if the direction of these two vectors are same, these two vectors are said to be equal vectors. So vector A and vector B are equal if and only if mod of vector A are equal, mod of vector A is equal to mod of vector B, and A cap is also equal to B cap. Means the two vectors are equal if their magnitude are same and their direction is same. Negative of a vector. Negative of a vector means a vector of same magnitude but of opposite direction. Suppose this is vector A. This is again a vector. It can be written as minus A, provided the length of these two vectors are same. Their direction are exactly opposite, then these two are also called opposite vector. Null vector or zero vector is defined as a vector whose magnitude is 0 and has no specified direction. Null vector doesn't have any direction. If we multiply by vector by a scalar, only its magnitude changes. Suppose this is vector A. If I write vector B, which is equal to 2 times vector A, so it means the magnitude of vector B is equal to 2 times magnitude of vector A. But B cap is always equal to A cap. So if we multiply by vector by 2, it becomes of double length. This is 2 times vector A. Its length will be double, but its direction will remain same. This is the meaning of multiplication of vector by a scalar. The magnitude increases or decreases, whereas the unit vector will remain same. Division of two vector is not defined. If I say what is I cap by I cap, so usually you can say it is 1, but this is wrong answer. It is not defined, because the division of direction is a sense whose division is not defined. So vector is made up of magnitude and direction. So if we divide the two vector, means we are going to divide the two direction which is not defined. So I cap is not defined, or vector A divided by vector B is also not defined, never exist. Multiplication of vector is either by cross product or by dot product, which we will discuss later. The vector multiplication is defined as A dot B or A cross B, and these two definitions, these two products are totally different. A dot B is different and A cross B is different. Now how to draw a vector 5 cap. So first we will discuss how to draw a vector of 5 cap unit. Suppose this 5 is in meters, so I will draw a line segment which is 5 meter long. This is 5 meter. I cap means it is along positive x axis. So I will start a vector, drawing a vector. This vector, its length is 5 and its direction is along positive x axis. So it is 5 I cap. I can also draw it here. I can draw this vector here also. This is also 5 unit, and its direction is I cap. This is also 5 I cap. This is also 5 I cap. Irrespective of position, you have to choose a vector whose direction is along positive x axis and whose length is 5 unit. So this is 5 I cap. Next one is how to draw a vector of minus 2 I cap. So we will choose a length, a vector, a line segment whose length is 2 unit. This is 2 unit, and put an arrow along negative x axis in this direction. So a vector, this is 2 unit, and we will put a line arrow in this direction. So it is minus 2 I cap. The length of this is 2 and the direction is minus I cap. I can put it here also. I can draw this vector here also, provided its length is 2 and the direction is along negative x axis. Triangle law of addition of vector. As we know, suppose this is vector A, this is vector B. I want to add these two vector. So we will put this vector A here. I will bring this vector B without changing its magnitude and direction and put the tail of this B on the head of vector A, and join the tail of vector A to head of vector B. Then this C will give me vector A plus B. This is called A plus B, and this way of adding a vector is triangle law of addition of vector. This is vector A, this is vector B, vector A. This can also be done as this is vector B, this is vector A, and this is vector C. If you see this C1 and if you see this C2, these two are actually same. So either A plus B is also equal to B plus A. And after addition law, we will discuss how to subtract two vectors. Suppose this is vector A. So I will write vector D, which is equal to vector A minus vector B. So subtraction of two vectors is nothing. This can be written as A plus minus of vector B. So subtraction of two vectors is also like addition with a positive vector and a negative vector. So I can write this. This is vector A, this is vector B. So this is vector minus B, this is vector minus B. So I will put it here. This is vector minus B, this is vector A, this is vector minus B. So if I join this tail and head, this is actually vector D, which is equal to vector A minus vector B. So subtraction of two vectors is nothing, it is addition of a positive vector and a negative vector. Now, how to write two-dimensional vector. As here we have discussed how to write 2 I cap, how to write 3 I cap. Now we'll discuss how to draw vector A, which is equal to 2 I cap plus 3 j cap. Now this vector A can be written as vector P plus vector Q. Now vector P here is 2 I cap and vector Q here is 3 j cap. This is P and this 3 j cap is Q. Now I will put this is vector O to P, this is vector P, 2 I cap. I draw a vector of length 2 unit along positive x axis, and 3 j cap. I draw a vector, this is vector 3 j cap, whose length is 3 unit and which is along positive y axis, and join the tail of this 2 I cap and head of this 3 j cap. Then it will give me vector A, which is equal to 2 I cap plus 3 j cap. Now the length of this vector A, the length of this vector A means mod of vector A is equal to, this is 2 and this is 3 and this is 90 degrees. So we can say this is equal to root over 2 square plus 3 square. It will give me root 13, which is magnitude of vector A. A cap, as we know, A cap is vector A divided by mod A. This is called unit vector of vector A. Now we know vector A is 2 I cap plus 3j cap, and mod of vector A is root 13. So A cap is 2 by root 13 I cap plus 3 by root 13 j cap. Now this 2 by root 13 is also called cos alpha, and 3 by root 13 is also called cos beta. This is alpha and this is beta. They are sometimes represented by L and M, also called direction cosine. Now another question is, draw vector B which is equal to 4 I cap minus 3 j cap. Now first I will write vector B as vector P plus vector Q. Now here vector P which is equal to 4 I cap. Now vector Q can be written as minus 3 j cap. So first I draw a vector P. This is 4 I cap. This vector P is 4 I cap. It is 4 I cap. Its length is 4 unit and the direction is along positive x-axis. This is vector P. And vector Q, its length is 3 unit and it is minus j cap. So I will draw a vector which is downward. Its length is 3 and the direction is minus j cap. So it is minus 3 j cap. Now by using triangle law, I will add these two. So I will draw a vector starting from here to here. This is vector B. It is 4 I cap minus 3 j cap. So this is vector B which is equal to 4 I cap minus 3 j cap. Now if I want to know what is mod of vector B, magnitude of vector B. So mod of vector B is root over the length of this vector B can be written. The length of this square means 4 square plus 3 square. So it comes out to be 5 unit. Now B cap. B cap is simply vector B divided by mod of vector B. It is equal to vector B means 4 I cap minus 3 j cap divided by, it is 5. Mod of B is 5. So it is 4 by 5 I cap and minus 3 by 5 j cap. So here cos alpha is 4 by 5 and cos beta is minus 3 by 5. Means this is your beta and this is your alpha. Now see how to write vector R, that is equal to 3 I cap plus 4 j cap plus 4 k cap. Now first we will draw x axis, y axis and z axis. This is our x axis, y axis and this is z axis. Now as we know, this is equal to vector R which is equal to vector A plus vector B plus vector C. First we bring back vector A, then we will bring vector B. This is vector A plus V which is of green color. Now this is vector C. This is called vector A plus B plus C. Here vector A is 3 I cap. So I will draw a vector which is equal to 3 I cap. So this is 3 I cap. Second is plus 4 j cap. So I will put a vector like this. It is 4 j cap. This is 4 j cap. And third one is 4 k cap. So plus 4 k cap. So this is 4 k cap. So if I join this origin to the starting point here, it is vector R. This is the way to write the three-dimensional vector. Now first we will calculate the magnitude of vector R. Magnitude of vector R is actually the length of this O to this point P. So length of this vector is equal to mod of vector R, which is equal to root over this 3 square plus 4 square plus 4 square. It is this square plus this square plus this square. This is magnitude of vector R, which is equal to root over 9 plus 16 plus 16, which is equal to root over 41. Now resultant of two vector. Now how to write the resultant of two vector? Now first we will discuss how to take the angle. The angle between two vector is defined as, suppose this is vector A, this is vector B. So the angle between two vectors is defined as, if I join the tail of these two vector, this is vector B, the angle between the two vector is the angle whose value lies between 0 and 180. The angle between two vector always lie between 0 and 180. So it is theta. Watch this clip. See, this is vector A, which is equal to 7 I cap plus 4. This is vector B, which is equal to 5 and 14. So how to add these two vector? First we will bring this vector A here. Then again we will bring this vector B and put it on the head of vector A. This C vector is the resultant of vector A and vector B. So this is vector A, this is vector B. So these components, this is 7, is 5. So it is equal to 12. So vector C is 12 I cap and 18 j cap. So this is the way to add the components of the two. Now in the same way, this is our vector A. Suppose this is vector A, this is vector B. Now we have to add these two vector. So I will bring this vector B from here to here. This is vector A, this is vector B. Angle between these two is theta, so this angle is theta. If I join this will give me vector C, which is equal to vector A plus vector B. So this is vector C. Now if I drop a perpendicular from here, so this length comes out to be B cos theta. It is B cos theta. This length is B sin theta. So I can say the magnitude of vector C is root over this square plus this square, because it will form a right angle triangle. So magnitude of vector C can very easily be calculated by, see this green triangle. This is actually a right angle triangle. So I can say vector C is equal to A plus B cos theta ka whole square plus this B sin theta ka square, which comes out to be magnitude of vector C is root over A square plus B square plus 2AB cos theta. Now since the magnitude of vector A plus B is equal to C, is magnitude of C. Now as we know, C is equal to root over A square plus B square plus 2AB cos theta. If I put theta is equal to 0, means suppose this is vector A and this is vector B. If the angle between this vector A and vector B is 0, so in that situation we can say this is vector A plus this is vector B. This is vector A plus this is vector B will give you vector C, that is equal to root over A square. The magnitude of this vector C is root over A square plus B square plus 2AB cos 0. Cos 0 is 1. So we get root over A square plus B square is A plus B. So magnitude of vector C is simply A plus mod of B. So this is the maximum possible value of C. Again, though these three vectors are not forming triangle, but this is called triangle law of addition of vector. So this is the maximum magnitude of vector A plus vector B. If theta is 180 degree, suppose this is vector A and this is vector B. As we know, these two vectors are opposite. So if I add this vector B here, this is vector B. So the resultant is this vector C. So resultant of vector C is written as root over A square plus B square plus 2AB cos pi, and we know cos pi means cos 180 is minus 1. So this is equal to root over A square plus B square minus 2AB, which is equal to mod of A minus B, or It is mod of A minus mod of B. So the resultant is this. This is the minimum value of vector A plus B. So minimum value of minimum is mod of A minus B. It is possible when the angle between the two vector is 180 degree. Now, as we know, the magnitude of vector C, we know this is vector A, we know this is vector B, we know this vector is resultant of vector A and B. This is vector A plus vector B, which is called resultant, that is called C. We can say the magnitude of C is always less than mod of A plus B. As we have already calculated, the magnitude of C is maximum and is equal to A plus B, and the minimum value of magnitude is mod of A minus B. So the maximum value of this is A plus B and maximum minimum value of C is mod of A minus B. So we can say mod of vector A plus B always lies between mod of A minus mod of B and mod of A plus mod of vector B. Mod of this vector A plus B always lies between mod of A minus mod of B and mod of A plus mod of B. Now how to add the two vector? Now it is given that vector A, that is equal to 2i cap plus 3j cap, and vector B, that is equal to 5i cap minus 6j cap. Then we have to add the find the magnitude of vector A plus B. As we know, vector A plus vector B is equal to, I will add I cap with the I cap, so it is 7i cap minus 3j cap. This is vector A plus B, and let it be vector C. So mod of this is, mod of vector C is mod of A plus B, mod of A plus B, which is equal to root over 7 square plus 3 square, which is equal to root over 58. So this one is the right answer. This question says two forces each equal to P by 2 act at right angle. Suppose this is force F1, which is equal to P by Q, P by 2. This is force F1. The another force is F2. This is F2. It is also equal to P by 2. These forces are mutually perpendicular. So we have to calculate the resultant. So I can say F resultant is equal to root over F1 square plus F2 square plus 2 F1 F2 cos 90, because the angle between these two vector is 90 degrees. So I can write the resultant of these two is root over F1 square plus F2 square plus 2 F1 F2 cos 90. So it comes out to be F resultant is equal to root over, as we know cos 90 is 0, so this term becomes 0. So it is equal to P by 2 square plus F2 means P by 2 square, which is equal to root over 2 times P by 4, or this is equal to P by root 2. So the answer is P by root 2, this one. The vector sum of force 10 Newton and 6 Newton can be, as we know, let this force F1, that is equal to 10 Newton. Let this force F2, which is equal to 6 Newton. So we know the resultant of F resultant, that is equal to F1 plus F2, and we know the minimum value of F1 and F2. Resultant of the minimum is F1 minus F2, which is equal to 10 minus 6, that is equal to 4 Newton, and the maximum is F1 plus F2, that is equal to 10 plus 6, that is equal to 16 Newton. So the resultant must lie between 4 and 16. So we can say 2 Newton. This is not possible. The minimum value of this resultant can be 4. 8 Newton, it is possible. 18 Newton is again not possible. 20 Newton is also not possible, because the resultant lies between 4 and 16 Newton only. Given that a vector A, that is equal to, this is vector A given by I cap plus 2j cap minus 3k cap. Now when a vector B is added to A, means this is vector B added to vector A, means this vector A will give a unit vector along x-axis. As we know, the unit vector along x-axis is I cap. So I can say vector B plus vector A is I cap, or vector B is equal to I cap minus vector A, which is equal to I cap minus vector A, means it is minus I cap minus 2j cap plus 3k cap. So this will cancel out. We get vector B as minus 2j cap plus 3k cap. So this is the answer. The resultant of two vector of magnitude 2a and root 2a. So magnitude of vector A, let it be vector P, let it be 2a, and let the vector Q be root 2a. And the angle between these two is theta, and it is given that the resultant is root 10a. So we can say resultant is equal to root over p square plus q square plus 2pq cos theta. So this is the resultant. So resultant is equal to 10a root 10a, which is equal to p square. We know p square means 4a square root over 4a square plus q square means 2a square plus 2pq means 2 into 2a into root 2a into cos theta. So this a will cancel out. After squaring we get it is equal to 10, which is equal to 4 plus 2 plus 4 root 2 cos theta. So from here we get cos theta is equal to 4 plus 2, it is 4 by 4 root 2, that is equal to 1 by root 2. So theta is equal to 45 degree. So the angle between vector A and B is 45 degree. This is the answer. Now in this question, given that vector P, which is equal to vector A minus vector B, and mod of P is equal to mod of A plus mod of B. A plus B means mod of A and mod of B. So we can say mod of A plus P is equal to mod of A plus mod of B. So I can say mod of P is equal to mod of A minus B, which is equal to root over A square plus B square minus 2AB cos theta. Whereas mod of P is also given that it is A plus B. So it is A plus B whole square, that is mod of P square, which is equal to A square plus B square minus 2AB cos theta. So from here we get A square plus b square plus twice ab is equal to a square plus b square minus 2ab cos theta. So this a square b square will vanish. We get cos theta is equal to minus 1 or theta is equal to 180 degree.